Good morning, ma'am. Myself, C. Varundeja. I am from CSCC section, third year. Today, my topic is evaluating performance of a model. The outline is Introduction to ML Model Evaluation, the importance of model evaluation, common evaluation matrix for a classification, the common evaluation matrix for regression, and train test for slipped method, and cross validation techniques, and confusion matrix and a delivered matrix, and a model validation and deployment, and conclusion and the best practices. The introduction to model evaluation. Model evaluation is a critical step that assuming how well a machine learning model performs on screen data. It helps the understanding the accuracy and reliability of the model, and the proper evaluation ensures that the model generalization will be beyond the train and data set. And the importance of model evaluation. The evaluation identifies the potential overfitting or underfitting issues in the model. It guides the selection of the best model among the multiple candidates. Reliable evaluation matrices are the essential for making informed deployment decision. Most common evaluation matrices for the classification. Accuracy measured the propagation of current predictions out of total predictions. Precautions of recall provide insights into a false positive and the false negative respectively. And the F1 score balanced the premises and recall into a single matrices for a better assignment. And the common evaluation matrices of regression means the absolute error, measured average magnitude of error in predictions, and mean squared errors emphasize the large errors by the squaring them, and R squared indicates the propagation of variance in the target explained by the model. And train test slipped method, the data set is divided into separate training and test sets, and the model is trained of the on the training set, the evaluation of the test set, and the model provides the initial estimate of models and performance on screen data. And the cross validation techniques. The cross validation involves the data into manipulates the floods and reboots the testing, and clay floods cross the validation of rotates the test to hold all the partitions to reduce the bias. It enhances the reliability of the performance estimates, especially with the limited data. And the confusion matrices are derived matrices. A confusion matrices summarize a true positive, false positive, and a true negative and the false negative from the matrices like accuracy, precautions, recall, and F1 square are derived. It provides the detailed insight into the types of errors made by the classifier, and the handling the using matrices like precautions, recall, and the F1 square instead of accuracy alone. Techniques such as the resampling or sympathetic data generation can balance classes. Proper evaluation imbalance prevent a misleading performance assignment. And the model validation and the deployment. Validation confirms that the model performs consistence across the different data. It has a importance of monitor model performance continuously after a deployment. Ongoing evaluation helps the detecting the model and the maintain accuracy over time. Conclusion and the best parts. Always select a appropriate matrices aligned with the specific problem and goals. Employment multiple evaluation techniques for obtained comprehensive and performance view. Regular update and the validation models to ensure the sustained performance in productions. Thank you, ma'am.